Welcome to Arky Techno AI, your go-to channel for in-depth explanations of science, technology, and how they shape our world. Today, we're diving into a topic that's critical for our future: the science behind climate change. Climate change involves significant shifts in global temperatures and weather patterns over time. While natural climate variability has always existed, the current rate of change is alarmingly fast and primarily driven by human activities. This rapid change is mainly due to the increase in greenhouse gases like carbon dioxide and methane, which trap heat in the Earth's atmosphere. Human activities, especially the burning of fossil fuels such as coal, oil, and natural gas, have significantly raised the levels of these gases. This intensification of the greenhouse effect is causing the Earth's surface temperature to rise, leading to various environmental changes. Beyond industrial emissions, deforestation reduces the number of trees that can absorb CO2, worsening the situation. Many people mistakenly equate climate change solely with global warming. However, it includes a broader range of changes such as more frequent and severe weather events like hurricanes and droughts, shifting wildlife populations and habitats, rising sea levels, and more. Each of these changes presents unique challenges to the survival of many species and the well-being of human communities. Understanding the science behind these changes is crucial for developing effective strategies to cope with and mitigate the effects of climate change. By comprehending how human activities alter the atmospheric balance, societies can better prepare for the future, fostering more resilient communities and ecosystems. The altered greenhouse effect: human impacts on a natural process. The greenhouse effect is a natural process that warms the Earth's surface. It occurs when the sun's energy reaches the Earth's atmosphere. Some of this energy is reflected back to space, and the rest is absorbed and re-radiated by greenhouse gases in the Earth's atmosphere. The absorption and re-radiation of heat energy maintain the Earth's temperature at a level suitable for life. However, human activities, particularly industrialization and the combustion of fossil fuels, have increased the concentrations of these greenhouse gases, leading to an enhanced greenhouse effect. This enhanced effect causes more heat to be trapped in the atmosphere, which increases global temperatures. Such temperature increases can lead to severe climatic alterations and extreme weather conditions. Carbon dioxide, CO2, is the primary greenhouse gas emitted through human activities, and it is responsible for about 3/4 of the warming impact. Methane, another significant greenhouse gas, is released during the production and transport of coal, oil, and natural gas, and it has a much greater ability to trap heat in the atmosphere than CO2. Albeit it stays in the atmosphere for a shorter period. The result of these increased emissions is a disruption of the natural balance of the Earth's atmospheric system. This disruption contributes to long-term changes in climate patterns, significantly impacting ecosystems, human health, and economies globally. Understanding the altered greenhouse effect helps in identifying the most impactful areas for action to mitigate climate change. Scientific evidence: ice cores and satellite data. Scientific evidence for climate change is overwhelming and multifaceted, ranging from ground-based observations to advanced satellite data. Ice cores, for example, are one of the most revealing sources of historical climate data. By analyzing layers of ice that have accumulated over thousands of years, scientists can extract information about past atmospheric conditions, including greenhouse gas concentrations. These ice cores have shown that current levels of carbon dioxide and methane in the atmosphere are significantly higher than those seen in the past 800,000 years. This data directly correlates with the industrial activities of humans, particularly since the onset of the Industrial Revolution. The steep increase in greenhouse gases coincides with this period, providing a clear link between human activities and climate change. Satellite data also plays a crucial role in understanding climate change. Modern satellites monitor Earth's weather and climate, providing data on temperatures, sea levels, ice cover, and atmospheric gases. These data have shown consistent warming trends and an accelerating rate of sea level rise, further confirming the widespread impacts of climate change. Both ice cores and satellite data not only illustrate the rapid change in our environment, but also highlight the urgent need for action. They serve as a critical foundation for informing policy decisions and scientific research aimed at mitigating the effects of climate change. This evidence is crucial for building strong strategies that can effectively counteract the current trends. Ecological and climatic consequences, from weather to water. The impacts of climate change on ecological systems and weather patterns are profound and far-reaching. Rising global temperatures have led to alterations in weather patterns, resulting in more frequent and severe weather events. For instance, the increase in Earth's surface temperature has been linked to an increase in the intensity and frequency of hurricanes and tropical storms. These storms not only cause immediate damage, but also have long-term effects on the ecological balance and human communities. Sea level rise is another significant impact of climate change, caused primarily by the melting of ice caps and glaciers, and the thermal expansion of seawater as it warms. Rising sea levels threaten coastal habitats and are already affecting low-lying islands and coastal cities, increasing the risk of flooding, which can lead to displacement of communities and damage to infrastructure. The effects of climate change are not limited to physical changes, they also impact biodiversity. Warmer temperatures and altered weather patterns affect the migration patterns, breeding cycles, and habitat ranges of various wildlife species. These changes can lead to mismatches in ecological interactions, such as those between pollinators and plants, potentially leading to declines in both plant and animal populations. Moreover, the impacts on water resources affect both human populations and wildlife. Changes in precipitation patterns are expected to lead to more severe droughts and floods, affecting water availability for drinking, sanitation, agriculture, and energy production. The comprehensive understanding of these ecological and climatic consequences is essential for developing effective adaptation and mitigation strategies to safeguard our planet. One of the most effective strategies to combat climate change is the transition from fossil fuels to renewable energy sources. Renewable energy, including solar, wind, hydro, and geothermal, emits little to no greenhouse gases and is a sustainable alternative to traditional energy sources. The adoption of renewable energy not only helps reduce the atmospheric concentration of CO2, but also decreases air pollution, improving public health. The technology behind renewable energy has advanced significantly, making it more efficient and cheaper to produce. Solar panels and wind turbines have become more accessible to the general public and businesses, paving the way for a decentralized energy system. This shift not only reduces dependency on fossil fuels, but also empowers individuals and communities by providing more control over their energy sources. Governments around the world are increasingly supporting renewable energy projects through subsidies and incentives, which helps accelerate the transition. These policies are crucial for expanding the reach of renewable technologies, making them a central part of the energy landscape. The global shift towards renewable energy is also creating new job opportunities, contributing to economic growth in a sustainable manner. In addition to reducing emissions, renewable energy systems can also provide more stable and secure energy supplies. Unlike oil and gas, which are often concentrated in certain regions and can lead to geopolitical tensions, renewable resources are generally more evenly distributed around the world. This can lead to a more equitable and stable global energy market. Adaptation strategies are essential for coping with the inevitable impacts of climate change. These strategies involve making adjustments in ecological, social, or economic systems in response to actual or expected climatic changes. Building resilience into infrastructure is a critical aspect of these strategies, helping communities withstand and recover from the effects of extreme weather events and other climate-related challenges. Infrastructure resilience can be enhanced by designing buildings and roads that can withstand higher temperatures and more extreme weather events. For example, raising the levels of bridges and roads can prevent damage during flooding, and using heat-resistant materials in construction can reduce the risk of damage from wildfires. Additionally, enhancing the flexibility of water supply systems to handle both floods and droughts is crucial for maintaining water availability during varying climatic conditions. Urban planning plays a vital role in adaptation strategies. Green infrastructure such as parks, green roofs, and wetlands can help manage rainwater runoff, improve air quality, and lower city temperatures, mitigating some of the adverse effects of climate change. Furthermore, integrating climate considerations into land use planning and building codes can significantly reduce future climate-related risks. Governments and communities must also focus on enhancing the resilience of the agricultural sector. This includes developing crops that are more resistant to droughts and pests, improving water efficiency in farming, and adopting more sustainable farming practices. These measures can help ensure food security in the face of changing climatic conditions. The fight against climate change requires a united global effort. International cooperation is critical, as climate change is a global issue that transcends national borders. Agreements like the Paris Agreement are pivotal, as they commit countries to reducing their carbon emissions and adapting to the impacts of climate change collectively. Such international frameworks foster shared goals and accountability, encouraging nations to work together towards a healthier planet. Individual actions also play a crucial role in tackling climate change. Simple measures like reducing energy use, choosing sustainable transport options, recycling, and supporting local and sustainable food choices can collectively make a significant impact. Public awareness and education on climate change can empower individuals to make informed decisions that contribute to the broader goal of climate mitigation. The synergy between individual efforts and international agreements creates a robust response to climate change. While governments can enact policies and provide resources, individual actions can uphold and enhance these efforts, creating a comprehensive approach to addressing climate change. This dual approach ensures that both the causes and effects of climate change are addressed, providing a sustainable path forward. Empowering individuals and communities to take action not only helps reduce emissions, but also builds a culture of sustainability that can influence policy decisions and corporate behaviors. By fostering a sense of responsibility and possibility, individuals can inspire change at multiple levels, from local communities to global policies. The challenge of climate change offers an opportunity to innovate and reimagine our relationship with the environment. By understanding the science behind climate change and taking decisive action, we can mitigate its impacts and foster a sustainable future. It is crucial for each person to recognize their role in this global effort, whether through education, personal choices, or advocacy. Renewable energy adoption, sustainable practices, and resilience building in infrastructure are just a few of the strategies that can drive meaningful change. These efforts require collaboration across all levels of society, from individuals to international bodies, to be effective. It is through unity and collective action that we can address the pressing issue of climate change. This moment in history calls for bold leadership and a commitment to action from everyone. Educate yourself about climate change, advocate for policies that support sustainable practices, and implement changes in your daily life that contribute to a healthier planet. Remember, the actions we take today will shape the future of our planet and future generations. By taking action now, we can ensure a resilient, vibrant, and sustainable world. It's time to act boldly, innovate, and ensure that our planet remains a thriving home for all its inhabitants. Let's embrace this challenge and work together to secure a sustainable future for everyone. Don't forget to subscribe to Arky Techno AI for more in-depth explorations of science, technology, and the future. Let's work together to create a brighter, sustainable future for all.